privacy restricted access. Hello. Okay, we are going. I want to know if anyone can hear me. My name is JF. I'm from BotFactory. Hi. I'm sorry, I can't read Korean. I wish I could say your name. Maybe that means I need to travel more. Let me just switch to an actual picture of me. Hello. Right now I am in one of our boardroom spaces, and I have my presentation ready to go. And I just wanted to quickly move on because we were a little late getting the live stream ingestion settings correctly configured. But after I cleared out that, I got things going. So without further ado, let's go on from here. There's a chat window on our YouTube link, or on the actual live stream. You can ask questions there. I see I have an email from Rob Lewis. It says restricted access. I'm not sure what that problem may be, because this is a public link. Everyone should be able to see this and comment and view. But if you have trouble seeing this live stream, don't worry, it's going to be saved on YouTube. We're going to share a link with everyone. Oh, it's the same link, so you can use this later. Going from there, let's start talking. So, people who have been using our printer have found out, or at least we've seen a lot of people trying to do what I would consider custom boards. Most circuit boards, typically, if they don't have through-hole components, they also have holes for holding components or attachments of connectors, battery connectors, or battery clips, or other elements, like, for example, in our case, bearings. But all in all, typically you need a substrate that has to be cut down to size, and you have to have holes placed in them. The way our printing process works is that it's not necessarily possible for us to drill out holes or cut things down to size. We do sell accessory tools that allow you to at least do the cutting. We do sell a pair of PCB shears that you can use for cutting afterwards. It should be also noted that milling and cutting FR4 can be hazardous in large quantities. That's typically why we haven't included any milling or anything like that, because it would require concurrent vacuum and HVAC systems to make sure that there's a relatively dust-free process or fabrication process. But there are ways around it. We've kind of planned ahead for that. And what I'm going to be doing in this webinar is talking about how you can use pre-cut pieces of FR4 substrates or Kapton, really doesn't matter, and using our printer to essentially work with those pieces so that you can get full usage out of your machine. An example of what I'm talking about right now is this. This is the piece of FR4 that I use in this webinar, and what I use to make. And basically, it's a fidget spinner, and there's a bearing right here, which typically sits right above, and there's usually a sort of flanged piece to hold your fingers away from the substrate so that this can freely rotate. And there are two other holes here for holding down the battery clip onto the pads so that it makes a connection and provides power. It's one-sided single layer. It's not terribly complex. And this is the assembled version I have in the video. It consists of essentially, pardon me. This is the actual version that I made. And consists of bearing, circuit board, clip, and when you take the battery, which is using my laptop, battery ran away from me. Essentially, when you connect the battery and you rotate it, Um, it actually says something. You can't quite see it, but it says "Hello World." I imagine the bitrate is not very good, but I will post actually high-quality videos of this thing operating so that you can sort of see it for yourself. But it's a simple design, programmable with a switch to do various settings based on an open source design that I altered so that we can make one. That being said, let's go on to the next step. Is there any other questions? I'm just going to check the live chat. I don't see any questions, so I'm going to move on to the next step. I just want to make sure that everything is coming through clearly. Okay. Okay, good. I just want to check my emails. No one else has emailed me. Rob, I hope you make it. If you don't worry. You're going to see the rest of this video elsewhere. Moving on to the next step. Okay, let's switch to the stream. Oh, by the way, can you hear me? Am I coming through clearly? Please let me know if you can. I'm going to be checking the chat every once in a while, seeing how everything is going. If you can't hear me, yeah, please let me know as soon as you can. Okay, so moving on to the webinar. So let's show you what we made here. Okay, so as I said before, this is the design. It's up close. You can see high quality image. And the edges of the board were just simply cut with a pair of shears. You can come with a knife. You can come with laser cuts even, apparently. FR4 is a fairly well understood material. Powerful lasers can cut it to shape. The holes were drilled out, and both with a simple drill press. And I just simply cut a piece of substrate that we typically include with every machine. Now, typically what happens is you print a board, you assemble it, and you cut it afterwards. And then if you have any drill points, you drill them in afterwards. We have found that's an effective way you can do it, but it's better if you have everything pre-cut beforehand and then print on top of it, because boards typically require a lot of flexing if you cut them. If you mill them out, it's not nearly as bad, or laser cut them. And if you have access to a routing system, you can print the board on a blank piece of FR4 and then put it in your machine for milling afterwards. However, you can invert the process by simply having your pieces cut, or if you have a service out there, there's plenty of services, they'll cut you pieces of blank FR4 for you, and then you can print, dispense, and assemble on top of them. That's the latter approach, and that's the recommended approach. You get better results, better yields. It's just an overall better way of doing it. Hopefully I'm going to be doing some more webinars, maybe where I get a board pre-made from another service, and then I print on top of it and assemble it, or I do this with Capton. But the general process here is essentially the, I guess, basic outline of how we do it. As I said before, the typical processes for making holes and cutting a substrate to shape is laser and what they call jig cutting or milling or something like that. But large milling machines can be used to do all these processes. Instead, we use basically blank pieces and a pair of shears to cut them down to shape, and then a mill press. I mean, the mill press we have is like $200. It's a very inexpensive design. I think the drill bits we've used probably more expensive. But the general idea is that you drill it out. In this photograph on the right, I'm using a jig because I'm cutting several pieces down. As I said before, I made a bunch of these, and so I sort of made a 3D printed jig, stacked a bunch of pre-cut pieces, and then drilled through them all. There's lots of ways of doing it. This way is just the most effective for, let's say, batch production, which is a great use for our machine. Any questions so far? Please hit me on the chat window. So next step is doing the upload. So let's step back one second. If I have pre-cut pieces, I need to tell the machine where my design is for it to print on it. So what's going to be happening is I'm going to be printing the outline of the design and then registering that piece to it, and then repeating the process where I print the actual traces, paste file, and pick and place. It's called mechanical details in certain softwares. It's also called, there's another name for it, mechanical details. There's like mechanical outline, cut points. There's really depends on your CAD tool, but they all provide them. And essentially, it's the outline for the design to for the manufacturer to know where they cut. But for our purposes, it's a useful file for us to print the outline. These are all Gerber files, just simple vectorized files that our machine can interpret and turn into images. You can upload a silkscreen file. It doesn't matter. You can even upload another trace file, as long as it defines the edges of your board. And you upload it as an outline and then as this trace file as well. So you use the same file twice, basically. Place the paper, you print with the cartridge, and you're printing with the conductive ink cartridge. And doing that, and then moving on to the next step, which is, as I said before, you upload the outline and you upload the trace files. Once you do that, you start printing. And you can see in this picture on the left, you can see that I've essentially aligned the design to fit within the sort of printed outline. Now, it doesn't have to be square. It can be round. It can be octagonal. It can be shaped like a star. It doesn't matter. It's just the outline of your design. Theoretically, you could use a piece of substrate and place it on there if it's transparent. That doesn't really matter. You want to have a pre-cut piece. This is how you place it. You don't have to leave the design there after you've printed it, and we'll get to that. We've come up with some new features to help you sort of align an existing board in whatever direction, and this is pretty interesting. But in this image on the right, I took it off, I connected it, and connected the traces using a multimeter to see the connectivity. We've gotten to a point now with inkjetting where it's extremely reliable on single and 2-layer and 4-layer boards. But I like to test every single one to make sure I have no shorts or opens. So do I have any questions? Nope. Okay. Moving on to the next step. So my board is fine. So I re-upload my outline and my paste file and place the board in any orientation. I could have, and this is the interesting part. So let's just say, for example, let's go back to this page. I placed my board like the image on the right. Just imagine there's traces there, and you can see all the pads and all the traces. But let's just say I placed it that orientation. I don't have to register it to the existing outline as I put there, because we have a new feature where it allows you can align your board by essentially having the machine select certain pads, moving the head to that pad, and saying that is pad so-and-so. SV2 will essentially reorient its design to be like, map it out, knowing exactly how your board is oriented. If you have a pre-made board, let's say, made with Oshbark or wherever, you can use SV2 for doing very rapid pasting and assembly of boards. So in this case, specific case, you can see here I'm essentially providing 2 reference points and moving the head to those points. So for example, you can see in that image on the left, I align the head using the dispensing head, and then I choose another pad, make sure it's centered, and I could have added more pads if I really want to get precise, but typically the machine will just ask for 2 pads. I typically try to choose the ones that are furthest from each other, and then the machine will go from there and do the adjustment. So you see on the image on the right, I just kind of placed it a little askew, and it didn't really matter. The machine figured out pretty quickly where it had to go and pasted everything correctly. there's no more questions, I'll move on to the next step. Just waiting for my chat window to reappear. Okay. All right, next step. So, assembly. This is perhaps one of the more complicated and involved processes when it comes to using our machine. And it's about half of the webinar covers this topic, and I thought I'd go into great detail. Word of note to users and potential users in the future, we're going to be doing more detailed videos of each process, printing, dispensing, and assembly, and amongst others, how to print thin traces, doing that kind of stuff. But I want to let you know that we're going to be doing more detailed stuff because I do skip a little bit of here and there because I really didn't want to go through the in-depth, how I designed it, how I built it kind of processes. We are making more tutorials in regards to, say, uploading images. By the way, check out our tutorials page. We have Mr. Michael Yang. He's been has been our intern for MTU in Singapore, and he's been doing a lot of great work for us, creating these very detailed descriptions of how to design for SV2. But moving swiftly on, I'm just going to kind of go through a quick overview of how the assembly process works. The files we use for assembling or pick and placing components is something called a centroid in rotation file. And it's typically exported from most CAD and EDA, electronic design application tools, as a .csv or a .tsv. But it's readable in Excel as a list of digits or numbers or words with headers for each. And they typically describe things like the X and Y coordinates of the components, the size of the components, which side of the board it's on, the type of board, or comments about the component, and most importantly, the rotation in degrees of the component from its zero rotation. That information it's given different names on the front headers, and in this page you can kind of see here we have to kind of help the machine understand what you're reading. In addition, we take millimeters. You need to give us files in millimeters. I've given files accidentally in mils or inches. We are an SI-friendly, standard inch and SNL, metric-friendly company. So if anything, please provide everything in millimeters. However, for footprints, it doesn't matter. You can provide that in millimeters or mils, but it would be best if you provide it in millimeters because you define that actually in the machine. Moving on. So as you see here, let me actually just go over this. When you upload the file, it's a .csv in this case, you have to essentially select what each header in your file means to us. Some of them are pretty simple. So the image on the left, the name of the part is just designator. X means X, for example. Rotation means rotation. But things like side don't matter to us because we're only assembling on one side. So you can click on, it's best idea to click on ignore. Now, the next step after doing this, you want to essentially define the size of the component. So in zero rotation. So we need to essentially provide its width and height. And once you have that information, you can insert it. Why is this important? Footprints are defined, the term footprint is defined very widely. Some CAD tools give us that information. For example, the one I use, Upverter, it does give me that information. And that's a good idea to provide that information in the tool head first. And there's one reason why we do that. There are lots of different components, and they often have very slight differentiations in size. So we recommend that instead of using what the CAD tool thinks the size is, you provide that information. So you're probably going to need a pair of calipers to measure each component. And when you define that information in this part of the process, I want you to essentially measure this with a pair of calipers and then input the information. You don't have to input it beyond a magnitude of beyond 1 digit. You can use up 3.2, for example, millimeters. You don't need to put 3.159 or something like that. It's okay. You can round up to 1 significant digit. I guess that would be. Now there's something important. So let's just say I'm using an SOIC 14. There's always a bit of debate. Do we measure the leads and the package when I'm including, for example, the thickness of the part, or do I just measure the body? Our computer vision system will identify the edges of the part, but will give significance to its rectangleness. Now, it's not a big problem for most caps, resistors, things like that. But when it comes to things like SOICs, where you see these leaded packages, we typically like you to measure, try to get as most rectangular as possible. This is an exception because if you look at a quad leaded pack, there's leads on all sides. So you measure the leads or you measure the package, it won't matter because it will just simply identify the square edges because it's just a quad lead, it's a big square. But if you have something like an SOIC, try to just measure the package and give it the most rectangular shape possible. If the part is not recognized by the machine, it will just simply return it back to where it came from. So that's going for you. If it has a trouble essentially matching the information that you provided with the image it sees. So in this 2 photographs, I say, try to provide the information that matches its most rectangular aspect ratio instead of actually providing leads. So after I've sort of defined all the footprints, this is what you'll get. And you see the blue, those means they've been approved. And you don't have to measure every single component. If there is 20 LEDs and they all have the same identifier as 1206, all footprints with the footprint designator of 1206 will have the same size. Keep in mind that some 1206s they're not all the same. I have LEDs and resistors in this design, and they have slightly different aspect ratios. So one of them had 1206 LED, the other one had 1206 resistor, written as its footprint designator. And that is all editable in your CAD or EDA tool. Okay, just moving on to check my questions. Okay, I have no questions. Please hit me up if you have any questions right now. Okay, moving on to the next slide. Okay, so once you've defined your footprints and aligned your board, you will see this page. This is your assembly interface. All the components that are placed here are going to be in a 0 rotation. All the components that are in your tape reels, your long reels of components, are in a 0 rotation. The components that you're loosely placing on your tray, that's the gray thing in the center, or on the left of center. That component tray, the components need to be oriented in their 0 orientation, which is defined in your footprint editor on your EDA tool. The tape reels, it's because of how the pins are oriented on the tape reel system, it's kind of, you have to place them in a certain way. So the machine already knows that those components are in the 0 rotation. Let's think about this. You have options for clicking through onto each of these tray or reels. You can see that on the right. Those are where you essentially for each component you want to select where the components are sitting. I'm just going to quickly describe that process right here. So When you're going through the assembly interface, first thing you do is you select the tape, tray, or reel for each component. If I select a reel, I'm going to be selecting similar components that you want to place. I can pick up to maximum 4 components on one reel. So if I click, if my components R1 to R4 are all, 200 ohm resistors or something like that, I place the 200 ohm resistor on the rail, and then I select R1. It's going to ask me if I have any other components, and I'm going to select R2, R3, and R4. And essentially those will be picked up first. If I'm placing them in a tray, I just place the components in the 0 orientation and then move on to the next component. So as a good sort of tip for you, I highly recommend trying out like one component at a time with reel to make sure that it's picking and placing everything correctly. And similar for the tray. And then once you get more and more confident, you do larger and larger batches. You can do a batch of up to, well, quite a few components. I think 50 is what we define it. So here's the video, or not video, but an image of the process that we go through. So I clicked on reel, and then I select the slot, and then I click OK. Then I remove using we provide these with each machine. These are just sort of sharp-nosed pick and place tweezers. I remove the tape, careful not to knock off the components in the process. And then I click place. And what happens is, depending on the size of the component, the machine will identify, you either pick and place its smaller tip or larger tip. So it goes over there, picks it up automatically, goes to the camera, makes sure it knows where the tip is, picks up a component, takes it to the camera, orients it. There's a motor inside the pick and place, so we'll orient it correctly. And then goes to the next step and places it on the defined location. And then I repeat the process with all my other components and hit heat, and then the whole thing is done. And there you go. Okay, so are there any questions? Okay, I don't see any questions here. Good news is that you're going to get a copy of this, of the presentation after this webinar. Also, this video is going to be, as I said before, this video is going to be online, and you can see it anywhere you would like. If you have any questions, the easiest way to contact us is simply go to our website and going through and sending us an email there. I have a question from Dr. B. Khan. Hey, Bruce. You skipped the gluing step. We did do an abbreviated version of the gluing step. But I'm going to go right back and talk about that right now. At this point, I'm trying to think what we do at this step. We essentially do there are a few steps in the process. There's one specific where you do a test run to make sure it's dispensing. I assume that you've done that. We can go into more detail about that in other videos where I actually go through each step of the process. But I've assumed essentially that you basically reloaded this cartridge and it is ready to go. If you would like, we will make sure we send you a sort of more detailed video when it is ready about that process. What else? Let me just switch to video again. Hello. So this is the dispensing kit, by the way, he was talking about. So it's essentially the machine will lead you through this process about how loading it and testing it. That's kind of why I made a more abbreviated version. The software kind of defines how you use it in some ways, but I want to go into more tips and so forth in the next webinar about that. Are there any other questions? We have, my goodness, how many people are watching this right now? 7 people. All right, if there are no more questions, I am going to call it a day here because I know everyone's very busy. As I said before, please send us an email by going to our website and sending us a comment, or email us at contact@botfactory.co, or send me an email on the link I sent you on that email. Just respond to that. I will see that as well. As I said before, SV2 is for sale right now. It's $16K. Comes with everything you see here. We also have Swing for sale. Similar process, but essentially the same machine, in at least for dispensing and pick and place. We can talk about that as well by email if you're interested. But thank you very much for your time, and talk to you soon.